Billions of us do something every single day that feels incredibly simple. We press play on a YouTube video. But have you ever stopped to think about what happens in those milliseconds right after you click? That one little action kicks off this invisible, ridiculously high-speed journey across the entire globe. So let's follow that data and see where it actually goes.
So you hit play. Your computer has to ask YouTube servers, hey, can I get that video? But how does that request even get packaged up? How does it travel? And how in the world does the video find its way all the way back to your screen and not, your neighbor's? That's the magic we're going to unpack right now.
Okay, so to make sense of all this, we're going to use a kind of roadmap. It's based on the first 4 layers of how networks talk to each other. Just think of these as the prep stages. They take your simple click and turn it into a request that's properly packed, addressed, and ready for its big cross-country or maybe even cross-continent road trip.
Right, so this first phase is all about getting your data dressed up and ready to hit the road. Think about it like packing a suitcase for a big trip. You can't just throw everything in there randomly, right? It all needs to be organized, folded, and labeled correctly so it gets where it needs to go.
First up, you've got the application layer. That's basically your web browser. It's the thing that says, hey, network, I need something. Then the presentation layer gets all the data formatted just right. And finally, the session layer kicks things off by opening a direct line, starting a real conversation with YouTube's server.
So that presentation layer, it's all about speaking a common language. Imagine if I sent you a document in some weird custom file format that only I have the software for. It would be totally useless to you. Well, for the web, that common language is stuff like HTML. This layer makes sure that when YouTube sends the web page data back, your browser knows exactly how to read it. No confusion. All right, our request is all packaged up. The conversation with the server has started. Now we hit the transport layer. And this is where a really critical decision has to be made. I mean, it's a fundamental choice that's going to affect everything that happens next.
And this is the core question it has to answer. Does this data need to get there perfectly, with every single piece checked and confirmed? Or does it just need to get there as fast as humanly possible, even if a few bits and pieces get lost along the way? The answer to that question determines which delivery method we're going to use.
And that brings us to our 2 main players, TCP, the Transmission Control Protocol, and UDP, the User Datagram Protocol. The easiest way to think about them is like 2 different delivery drivers, each with a very different personality. So TCP is the super careful, meticulous one. Honestly, it's kind of naggy. Before it even sends any data, it does this formal 3-way handshake to make sure the connection is solid. Then, after every single piece of data it sends, it stops and waits for a confirmation like, did you get that? If it doesn't hear back, it just sends it again. So the bottom line is, with TCP, you are guaranteed to get all the data and in the right order.
And then you've got UDP. UDP just goes. It doesn't ask for permission. It doesn't wait for you to say you got the last message. It just blasts a continuous stream of data out there and kind of hopes for the best. It is all about one thing, speed. It couldn't care less if you missed a piece of the message because it's already sending the next one. Okay, so let's think about this for a second. For a YouTube video, which one makes more sense? Do you want the reliable but maybe slower TCP to make sure you see every single frame? Or would you rather have the super fast but maybe slightly imperfect UDP to just keep the stream moving? What do you think?
Well, the answer isn't quite as straightforward as you might think. In fact, this is where the real genius of modern streaming comes into play. It's pretty clever. Yeah, it's kind of a trick question. The answer is both. YouTube brilliantly uses the strengths of each of these protocols to give you the absolute best experience. And it's actually genius when you see how it works. The web page itself, the like button, the comments, the video title, all of that has to load perfectly. A broken subscribe button is useless, right? So all of that is sent using reliable TCP. But the video itself? For a live stream, it's way better to miss one single tiny frame and keep the video playing than to pause the whole thing just to wait for a frame that's already in the past. And that's where speedy UDP is perfect.
Okay, so our data knows how it's going to travel, but how does it know precisely where to go on the other end? A massive server like YouTube's isn't just one thing, it's running tons of different services all at once.
This is where network ports come into the picture. The best way to think about it is like this. A server's IP address is like the street address of a huge apartment building. But once you get to the building, you still need to know which apartment to go to, right? Well, network ports are those specific door numbers. Each one leads to a different application inside the building.
So, for example, when you go to a secure website like YouTube, your browser just knows, okay, I'm heading for port 443. That's the universally recognized door for secure web traffic. If you were trying to, say, remotely log into a server, you'd probably go to port 22. These well-known ports make sure your request gets to the exact right service on that server. But hey, this is a two-way street. YouTube has to know where to send that video back to. I mean, your computer might have 10 browser tabs open, plus Spotify streaming music. To keep it all straight, your computer opens up a temporary, random port just for this one conversation. It tells YouTube, hey, send the video for this explainer back to me through, let's call it door number 57095.
So the whole conversation looks like this. Your request goes out from your computer to YouTube's address aimed at destination port 443. Then, the video stream comes back from YouTube to your computer's address aimed at that temporary destination port, 57095. This whole system makes sure the video data goes to your browser and your music stream goes to Spotify. It's a really elegant way to handle dozens of conversations at once.
So let's do a quick recap of this whole secret journey. Your click gets prepared by those upper layers. The network then chooses a delivery method, TCP for the reliable stuff, UDP for the speedy video stream. In YouTube's case, it uses both. And finally, network ports act like specific doors to make sure all that data gets to the exact right application on both ends of the conversation. So, the next time you see that dreaded buffering wheel spinning on your screen, you'll know what's really going on. You're not waiting for a piece of the web page to load. That's all handled by reliable TCP. Nope, you're most likely just experiencing a little hiccup in that fast and furious stream of UDP packets carrying the actual video. Kind of makes you think about that invisible digital dance in a whole new way, doesn't it?